Welcome back. We've heard how you entered robotics, explored what the industry is really like, and listened to some incredible stories from real deployments. Now I'd like to make this career feel even more real. Instead of asking the usual question, what's a typical day like? I'd like you to walk us through yesterday, hour by hour. What does a day in the life of a robotics startup founder actually look like?
That's one of my favorite questions because every day is a little different. Yesterday started at around 6:30 in the morning. Before I even got to the office, I checked overnight reports from a few robots deployed at customer locations. Many of our robots automatically upload health reports, battery levels, navigation performance, sensor status, completed missions, and any unusual events. Fortunately, nothing critical had happened overnight. One warehouse robot had paused briefly because a loading dock had been temporarily blocked, but it safely rerouted itself and completed its tasks. Those reports give us confidence that the robots are performing as expected, even when we are not physically present.
So, your workday begins before you even leave home.
Exactly. Autonomous robots don't stop working when we go home. They're operating in warehouses, factories, research facilities, and customer sites. Monitoring those systems is part of our daily routine.
What happens once you arrive at the office?
Around 9 a.m., our engineering team gathers for a short stand up meeting. Everyone shares what they are working on. Our perception team discusses improvements to object detection. The navigation engineers review path planning performance. The embedded systems team checks hardware prototypes. The software engineers report progress on our OS modules. The testing team summarizes yesterday's field trials. The mechanical engineers discuss improvements to the robot chassis. One thing that surprises many people is how collaborative robotics really is. A successful robot is never the result of one person's work. It's the result of many different engineering disciplines working together.
That really reinforces something you've mentioned throughout this podcast. Robotics is multidisciplinary.
Absolutely. A robot is like a living ecosystem. If one part doesn't work properly, the entire system is affected. That's why communication inside the engineering team is just as important as writing good software.
What came next yesterday?
Around 10:30 a.m., we moved into the robotics lab. We'd recently updated our navigation software, so it was time to test it. People sometimes imagine testing means pressing a button and watching the robot drive around. It's much more systematic than that. We repeat the same test dozens of times. Different lighting conditions, different obstacle layouts, different floor surfaces, different battery levels, different starting positions. If one small software update changes the robot's behavior unexpectedly, we want to discover that in our lab, not at a customer site.
That sounds a lot like how aircraft are tested before they carry passengers.
That's actually a good comparison. Safety and reliability are everything. A robot operating around people has to behave predictably. It needs to stop safely, avoid collisions, recover from unexpected situations, and continue operating without creating unnecessary risks. Testing gives us confidence that those behaviors are consistent.
What does lunchtime usually look like in a robotics company?
Honestly, it's usually full of engineering conversations. Even during lunch, someone might ask, what if we combine the camera data with the LiDAR differently? Or have we tried another localization algorithm? Curiosity doesn't stop because it's lunchtime. Some of our best ideas have actually come from informal conversations over coffee or lunch.
I think every engineering team can relate to that. What happened during the afternoon?
Yesterday afternoon, we visited a customer's warehouse. Watching robots operate in the real world is incredibly valuable. You quickly notice things that simulations can't fully capture. One forklift driver consistently took a shortcut through an area where our robot normally traveled. The robot handled the situation correctly by slowing down and waiting, but we realized we could improve efficiency by adjusting its preferred routes during busy hours. Small observations like that make a huge difference over time. Real environments constantly teach us how to improve.
So, deployment isn't really the end of the project.
Not at all. Deployment is the beginning of learning. Every customer environment is unique. Every building has different layouts. Every workflow is different. Every operator interacts with the robot differently. The more we observe, the better the next software update becomes.
What happens later in the day?
Around 4 p.m., our software team reviewed data collected during the warehouse visit. We examined navigation logs, obstacle detections, robot trajectories, battery usage, mission completion times. We also looked at situations where the robot hesitated before making a decision. Those moments are incredibly valuable because they often reveal opportunities for improvement. Sometimes a robot pauses because it genuinely isn't confident. Sometimes it's simply being overly cautious. Our job is to understand why.
That sounds like detective work.
In many ways, it is. People often think robotics is mostly about programming. I'd say it's equally about observation. Good robotics engineers don't just write algorithms, they study behavior. They ask, why did the robot choose this path? Why did it stop here? Why did it take longer today than yesterday? Those questions lead to better robots.
As a startup founder, your role must go beyond engineering as well.
Definitely. Around 5:30 p.m., I joined a meeting with a potential customer. They weren't interested in hearing technical details about SLAM or ROS. They wanted answers to questions like, can the robot improve productivity? How long will deployment take? How easy is maintenance? What's the return on investment? That reminded me of something I learned years ago. Customers don't buy robots because they're technically impressive. They buy solutions that solve real business problems. Technology is the means, not the goal.
That's a valuable lesson for anyone considering a career in robotics.
Exactly. Whether you're an engineer or an entrepreneur, success comes from understanding the problem before proposing the solution. The best robotics products begin with careful observation, thoughtful engineering, and continuous improvement.
Before we finish this segment, what's the most rewarding part of your day?
Watching a robot perform a task that once required constant human supervision, not because it's replacing people, but because it's allowing people to focus on safer, more creative, and more meaningful work. When I see a robot confidently navigating a complex environment after months of design, testing, debugging, and refinement, it's an incredible feeling. Every successful deployment reminds our team why we chose this profession.
What a fascinating look behind the scenes. Today, we've learned that robotics isn't just about building intelligent machines, it's about teamwork, testing, observation, continuous learning, and solving real world problems every single day. In our next segment, we'll look ahead. How close are we to fully autonomous warehouses? How will artificial intelligence reshape robotics? Which new careers will emerge? And where are the biggest startup opportunities waiting to be explored? Stay with us for part 5.